Hi everyone, myself Suresh, Department of Mathematics, Seekers Education. Today let's discuss a few problems based on ellipse. If the distance between the foci of an ellipse is 6 and the distance between the directrices is 12, then find the length of lattice rectum. So finding length of lattice rectum, LLR, length of lattice rectum is what? 2b square by a. So this is what he is asking us to find out. So in order to find out this length of lattice rectum, we must know what is a value and b value. So for finding a value and b value, what I'm going to do, I'm going to use the parameters given in the question. Distance between foci of an ellipse is 6 given. Distance between foci of an ellipse is what? 6. And distance between directrices is what? 2a by e, which is given as 12. Alright. So now this is the first equation, second equation. So by using these two, now can I divide these two? Let us divide these two. If I divide 2a is going to cancel. E by 1 by e gives me what? E square. Alright. So e square is going to be 1 by 2. Alright. 6 1s, 6 2s again. So 1 by 2, then eccentricity is going to be what? 1 by root 2. Cool. 1 by root 2 is eccentricity. Now what I'm going to do here, so I know that 2a is going to be 6. Alright. 2a e is what? 1 by root 2 is equal to 6. So 2 1s, 2 3s. So a is going to be what? 3 times of root 2. This is my a value. Alright. This is my a value. If a value you got, can't you find out b value? So what exactly the relation I'm going to use to find out b value here? So I know the condition, the relation between a, b and eccentricity. B square is equal to a square into 1 minus e square. Cool. So now in this case, b square is going to be what? A square value is what here? 9 into 2, 18. Can I write directly 18? A value is 3 root 2. A square is going to be 18. Alright. E square value is what here? E square value 1 by 2 I got. So 1 by 2. Alright. So 1 minus half is what? Half. 18 by 2 how much now? 9. B square is 9. Alright. A square value we got, A value we got, B value we got, B square value we got. So now let us find out length of lattice rectum. Now it is very easy now. Look at this. Length of lattice rectum is going to be what? Check. So 2 times of B square. B square is 9 here. Divided by A value. A value is what? 3 times of root 2. So 3 1s, 3 3s. So root 2 one time, root 2 one time. So what I'm going to get, tell me? 3 root 2 is the answer. 3 root 2 is available in B option. Option B is correct. Alright. So this is how you can just make a question given like on the basis of distance between foci and distance between directrices. Now let us have a look at the second question. See what exactly he has given in the second question. X square by a square plus y square by b square is equal to 1, where a greater than b given. Yes. Then it is horizontal ellipse. B a given ellipse, length of whose lattice rectum is 10. Length of lattice rectum is given in this question. Alright. So if its eccentricity is the maximum value of the function. Eccentricity is what? Maximum value of the pi t, maximum value of this function given. Then a square plus b square he is asking for. See, for finding maximum value of this function, what we do first? We'll just maximum. Let us look at this here. Let us write what he has given. First look at this, what he has given. Let me write. Length of lattice rectum. So which is 2b square by a is equal to 10 given to you. Alright. So from this can I just bring a relation? So 2 5. So b square is going to be what? 5 times of a. Let us have this aside. Okay. And eccentricity is what? Eccentricity is what? Maximum value of the given function. Maximum value of this. Let us maximize this. How do you maximize this? In order to maximize this, differentiate and equate with 0. Alright. So let's see now. If I maximize that, how do I maximize this? Differentiate the given function and equate with 0. If I differentiate with respect to t, d by dt of 5 by 12 is 0, dt by dt is 1. Alright, I am differentiating this. So 1, differentiation of t square is what? 2t, and if I equate with 0, what I am going to get, tell me? T value is going to be 1 by 2. Alright, t value is going to be what? 1 by 2. If t value is 1 by 2, then eccentricity is what? Tell me now. Maximum value of this given. So now what I am going to do is what? See, what I am going to do now is pi of t is going to be what? 5 by 12 plus 1 by 2 minus 1 by 2 square, which means 1 by 4. So LCM is what here? 12 in fact. So 5, 12 means plus 6 here. Alright, minus 3. Alright. So 3, yes. So 11, 8 by 12. 8 by 12 is what? Maximum value of this function. So maximum value of this function is what? 4 2s 4 2s, 4 3s. Alright, 2 by 3 I am getting, which is what? Eccentricity here. So now let us substitute over here. B square is equal to A square into 1 minus, so 4 by 9. So 4 by 9 I am getting. B square is equal to what? A square into what? 5 by 9. So B square is equal to 5 by 9. Now I know that B square value is what here? B square value is what here? 5A. So 5A is equal to A square into 5 by 9. Alright. So let me cancel this 5 over here. So A one time I will get cancelled. So A value is 9 I am getting. Alright. A value is 9. If A value is 9, then B square is going to be what? 45. Alright. So A value is 9, B square 45. So now what exactly he is asking for? He is asking us to find out A square plus B square value. A value is 9, A square is going to be 81 now. 81. B square value how much I got? 45. So 45 is nothing but how much? Unit digit supposed to be 6. 126 is the answer. Yes, 120. Yeah, 126 is the answer. Alright. So this is how we just go about this question. Next question is, let L be a tangent to the parabola y square is equal to 4x minus 20 at 6 comma 2. If L is also a tangent to this ellipse, then the value of B. Okay. So let's see what exactly he is talking about. Tangent to a parabola given at this point, and the tangent, that what is it? L is a tangent, that is that L is also a tangent to the ellipse given. So now what I will be doing here is, I will be using the tangency conditions over here. So I will be using the tangency conditions. Sir, how do you use the tangency condition here? Look at this. So let us try to find out what exactly the tangent equation is here. So I know the point, I know the parabola. Can't you find out tangent equation? Yes, you can find out. See, for finding tangent equation, what I am going to do is, look at this here. First of all, let us find out equation of L. Equation of L. Equation of L is nothing but tangent in fact. So y minus y1. y1 is what? 2. Okay. Slope of the tangent. Slope of the tangent. Slope of the tangent into x minus x1. See, how do I find out slope of the tangent? Slope of the tangent is equal to dy by dx at that particular point. Alright. So let me just write over here. So slope of the tangent. Slope of the tangent is what? Derivative of the given function at 6 comma 2. This is the point given to you, right? Yes. So now dy by dx is going to be what? Slope of the tangent. So how much here? So derivative of the function 2y into y dash is equal to 4. Alright. So now y dash is going to be what? 2 1s, 2 2s in fact. So 2 by y. Alright. 2 by y. So 2 by y is nothing but what? Actually, this is the point. What is the y coordinate of the given point? 2. So 2 by 2, which is 1. So this is the slope of the tangent. Y dash at this point is what? 1. So slope of the tangent I got 1. So y minus 2 is equal to 1 into x minus 6. So if I solve this, I am going to get what? Equation of tangent. Alright. So let us write this x minus y minus 4 is equal to 0. Else I will do one thing, simply let us write in the form of y is equal to mx plus c. If I write y is equal to mx plus c, that would be easy for us to compare in further, right? Y is equal to x minus 4. So what is, if I just compare this tangent equation with y is equal to mx plus c, what is m value here? Tell me, what is m value? M value, one second, y is, yeah. So m value is 1, c value is what? Minus 4. Y is equal to mx plus c I am getting. Alright. So yes, I got m value and c value. Then see, this is a tangent equation. This is also a tangent to what? Ellipse. See, I know the tangency condition for ellipse. So what is ellipse here? From the ellipse, x square by 2. So a square value is what here? 2. B square value is what? B square value is what? B. Alright. So now tangency condition with respect to ellipse is what? C square is equal to a square m square plus b square. This is the tangency condition with respect to ellipse. So why we are using this? We just need to find out the value of b. I know all the parameters other than b here. Alright. C square value how much? Minus 4 whole square, which is 16. A square value is 2. Alright. M value how much? 1. Alright. B square is b. So now b value is going to be what? 16 minus 2, which is 14. 14 is supposed to be the answer. Option B is the right answer. Alright. So we'll go forward. Look at the question. Let L be a common tangent to the curve 4x square plus 9y square is equal to 36 and 2x whole square plus 2y whole square is equal to 31. Then the square of the slope of the L. Then the square of the slope of the L. What do you mean by this? Square of the slope of the L is nothing but, if I say slope as m, is talking about m square. Alright, he is asking for m square. Then how do we just go about this? See, common tangent he has given. Common tangent to the curve. In fact, what is this? This is a circle, and that is also what this, you can just convert it to ellipse. Like how x square by like 4x square by 36 is x square by 9 here, plus y square by 4 is equal to 1. So now this is an ellipse, and this is going to be what? If I take look at this here, 4x square, so 4y square is equal to 31. So can I write like circle x square plus y square is equal to 31 by 4. Alright. So now this is a circle, this is ellipse. Alright. So common tangent. So common tangent, equation of tangent in slope form. Equation of tangent in slope form with respect to circle and with respect to ellipse. I know that. So how do we use that now? Tell me. Equation of tangent with respect to circle. So y is equal to mx plus r. R is what? Root 31 by 2. Alright. Into square root of 1 plus m square. Alright. So equation of tangent in slope form with respect to this is what? Y is equal to mx plus condition of tangency, just now I told that, which is what? Square root of a square m square plus b square. Alright. So now just comparing these two value, can't you get m square value? You can make it very easy. Look at this. See, y is equal to mx is a common term in both equations. So let us equate these constant terms. Job done. Look at this. Squaring on both sides. In fact, squaring on both sides. See, after equating this is equal to that. Look at this. Let me write one extra step. No problem. This is equal to that one. So root 31 by 2. Now square root of 1 plus m square. Alright. So squaring on both sides. If I do squaring on both sides, 9m square plus 4. So 31 by 4 into 1 plus m square. Alright. Simplify this. So 36 m square plus 16 is equal to 31 plus 31 m square I am getting. Alright. So now 31 square, 31 m square, shifting this side, so I am going to get what? 5 m square. So 5 m square is equal to what? 15. So 31 minus 16, 15, right? So 5 1s, 5 3s. So m square value is what now? M square is going to be 3. So he is asking for m square, which is what? 3 here. M square is equal to what? 3. M square is 3 here. Alright, so this is how we just make these sort of questions. Next, we'll go forward. See, which of the following points lies on the locus? Lies on the locus of the foot of perpendicular drawn upon any tangent to the ellipse. Okay, drawn upon any tangent to the ellipse, x square by 4 plus y square by 2 is equal to 1. Then from any of its foci is given. So what he is asking, which of the following points will be lying on the locus? So now you must know what is the locus here. So what is the locus? We need to find out what is the locus of the foot of perpendicular drawn upon the tangent to ellipse. See, we have a direct property here. The locus is going to be what? So locus of foot of perpendicular drawn upon any tangent to the ellipse is going to be what? Always auxiliary circle. So in this case, auxiliary circle's equation is what? X square plus y square is equal to a square, which is 4. So now tell me which of the following points will be lying over here. This is the locus here. That's it. This is a simple question. So what is the locus here? Auxiliary circle. Auxiliary circle's equation is what? X square plus y square is equal to a square. So now which of the following point would be lying on over here? Tell me. So tell me 1 square. So option C is correct. Check. Option C is matching or not. Let us substitute. Yes, minus 1 whole square plus root 3 whole square is equal to 4. Yes, 1 plus 3 is equal to 4. So 4 is equal to 4. So option C is matching. Option C is the right answer. So first of all, if you are aware of the property, alright, what is the locus here? The foot of perpendicular drawn upon any tangent of the ellipse or to the ellipse from its foci. That locus is going to be always auxiliary circle. The auxiliary circle equation is what? X square plus y square is equal to a square. A square value is 4 here. Just substitute the points. Option C is satisfying to the given question. Then that is the answer. We'll go forward. See, I just would like to give a hint of this question. You just need to make this. I'm not going to explain everything. So you take this question as homework, in fact. So take this question as homework. So what exactly he is talking about? Let's see. Look at this. Y is equal to mx and y, the line y is equal to mx and the ellipse intersect at a point P, okay, in the first quadrant. okay, intersect at point P in the first quadrant. If the normal to the ellipse at point P meets coordinate axis at -1 by 3 root 2 comma 0 and 0 comma beta, then beta is equal to dash. See, in fact, what I'm going to do is look at it. Just there's a simple question. This ellipse. Okay, this is ellipse given to you. See, why it is vertical ellipse? First of all, look at it here. X square by 1 by 2 here plus y square by what? 1 is equal to 1. Alright, is it clear? So, I'm just converting it to the standard equation. So, the given ellipse equation, I'm making it to a standard one. So, this is how it looks like. So, here a square is lesser than b square, right? So, now this is how the ellipse looks like. And now, what he has given here, look, y is equal to, I think this is not clearly visible. Then I'll use this pink color, okay. Alright, this is y is equal to mx line, okay. Y is equal to mx line and the ellipse intersect the point P, okay. These two are intersecting at point P. I don't know the coordinates of point P, let us say x1 comma y1, cool. Yes, in the first quadrant, if the normal to this ellipse at point P. So, what he is doing here, he is drawing normal to this point P. So, normal is nothing but, look at this, let us draw, normal is nothing but it will be perpendicular, in fact. So, if I draw the, look at this, it is not looking like normal, in fact. Just try to understand the diagram, please. See, if I just make a normal like this, let's say now, normal would be definitely perpendicular, okay. Please imagine this is a normal now. So, it is intersecting the coordinate axis at point what? At this point and this point, look at this here. So, first of all, we must write a normal equation here. How do we write normal equation? Simple. See, for finding tangent and normal equation, I'll tell you a simple trick. Look at this here. Y minus y1 is equal to slope of the normal into x minus x1. So, first of all, write the slope of the normal here. How do we write slope of the normal? First of all, you need to find out slope of the normal. For finding slope of the normal, you need to find out slope of the tangent. How do you find out slope of the tangent? Differentiate the given curve. Okay. Differentiate dy by dx of this particular curve at the point. What point? X1 comma y1. So, that is what slope of the tangent. Reciprocal with a negative sign, you will get slope of the normal. So, if I find out slope of the normal from this, I'll get something like slope of the normal equation. Alright, I know that he has given that this normal is what intersecting the coordinate axis at these 2 points he has given. Right. So, now this point he has given, what is that? Minus 1 by 3 root 2 comma 0, and this point is what? 0 comma beta. Okay, this normal is meeting coordinate axis at this point and this point. So, after writing this equation, these 2 points x comma y, this is not x1 comma y1. Okay, whatever the normal equation you get, substitute x comma y, take this as what? X comma y and x comma y. Okay, so substitute this point first, you will get one equation. Substitute this point, another time you will get another equation. Getting my point? And also we know that, see, this ellipse is what? This ellipse passes through the point P, x1 comma y1. So, now I will get another relation here. Look at this here, 2x1 square plus y1 square is equal to 1. Alright, so now you have this relation. Alright, you have this relation, you have this equation, and this equation is what? Normal equation, right? This normal equation meets the coordinate axis at this point and this point. After substituting these 2 points in this normal equation, you will get 2 equations. So, those 2 equations, and by help of this equation, you can find out x1 comma y1 values. If I find out x1 comma y values, then definitely you will get a relation. I mean, if I find out x1 and y1 value, definitely you will get a relation of 0 comma beta here. Why? Because 0 comma beta although passes through normal, if I substitute 0 comma beta, this one equation would be in terms of beta, right? One equation would be in terms of beta. Okay, so if I find out x1 and y1, you can make beta value very easily. So, this question you take it as homework. So, I just gave you a rough idea what to be done here. Just go in this manner and make the question. We'll meet you in the next class. Until then, bye-bye. Thank you.